Hello, I am Professor Rathod. Today I am going to discuss the topic gas turbine cycles. In that, we are going to see the improvements method of gas turbine. Basically, what is gas turbine? The gas turbine is one of an oldest one principal and improved version of, we can say, the windmill, but in that the gas turbine are of different types. It may be a open type and it may be a closed type. There are some different working mechanism with thermodynamics of gas turbine. There may be a Breton cycle, there may be a Joule cycle, there may be a Atkinson cycle. Also there are constant pressure gas turbine cycles and constant volume gas turbine cycles. Though gas turbine is the most satisfactory power developing unit among various means of producing mechanical power due to exceptional reliability, freedom from vibration, and ability to produce large power from unit of comparatively small size and weight. Rapid progress in gas turbine development was made as a result of industrial and military needs. A major part of power developed by the turbine is consumed for driving the compressor, which supplies compressed air to the combustion chamber. In that, this is a two shaft turbine. So as I told you, the cycle consists of compressor, combustion chamber, turbine. One is low pressure turbine, another one is high pressure turbine. So turbine 1 is carries a low pressure turbine, and the second turbine which carries the power, so it is called as two shaft turbine. The gas turbine improvement. Now our basic topic today we have selected is gas turbine improvements. So these are the methods: modification to basic gas turbine thermodynamic cycle, that is regeneration. It can be with heat exchanger. Then next one is intercooling, and next one is reheating. These are the basic methods on which we can come to the improvements. In a single shaft arrangement, the gas turbine is arranged to drive the compressor as well as to develop a network. It is sometimes more convenient to have two separate turbines, one to drive the compression and other provides the power output. The first or high pressure turbine is known as compressor turbine, and the second or low pressure turbine is called as power turbine. The diagram of regenerative, the first method is regenerative gas turbine cycle. In that we can able to see the compressor, condenser, combustion chamber, how the regenerator is happening. There is in between 1 to 2 there is compressor, in between 2 to 3 there is combustion chamber, 3 to 4 turbine, 4 to 5 we can say there is a regenerator, or also called as a reheater. Next we will see to the next slide the actual working of it. Now it is gas turbine with a regeneration. So again 1 to 2, 1 to 2 compressor, 2 to 3 we can say the combustion chamber. In that the fluid is provided into the combustion chamber, so that combustion chamber inside of the combustion chamber the combustion is takes place, so that the combustible material goes to the turbine. When that material goes to the turbine and falls on the blades of turbine, so the turbine rotates, it means the mechanical work is happen inside it. And as always is turbine is connected to the generator, there is generation of the electricity. Then it between 3 to 4 there is turbine. Next is 4 to 5 there is uh, we can say the regenerator or the heat exchanger. Now what is the exactly mean by a regeneration? Generation is generation of electricity. Once again, if the exhaust again coming to the heat exchanger or a regenerator, and again it generates the electricity or generates the power, that is nothing but the whole mean of what is called as gas turbine plant with a regenerator. So when the compressor starts, the air compresses it provides to the combustion chamber. By that time the pressure as well as the temperature is increases, then the combustible material provided to the combustion chamber, it goes to the turbine rotates, and then the exhaust of the turbine again goes to the a reheater also called as heat exchanger, and then after doing the work in the regenerator, the exhaust gas goes to the atmosphere. Let us understand the function of ts diagram ts diagram. T for temperature, S is entropy, as we know. This is the ts diagram. Gas turbine plant with regenerator. 1 to 2 the compressor. When the compressor starts, pressure as well as temperature increases. Then 2 to 3 2 to 3 2 to 3 the temperature as well as the entropy increases. Then 3 to 4 the temperature, when the expansion is taking place, the temperature is decreases. And then 4 to 5, that number 5 is in between 2 to 3. And then that number 6, when the gas goes to the atmosphere, that is in between 1 to 4 it is. So 1 to 2 1 to 2 1 to 2 the compressor is there, so in the compressor the pressure as well as the temperature increases. Then 2 to 3 the temperature as well as entropy increases. In between 2 to 3 there is a combustion chamber. 3 to 4 there is a turbine, the expansion is happening. By that time the temperature decreases and somewhat the entropy remains constant. Then 4 to 5, that point 5 is in between 2 to 3, that is in that heat exchanger is in between just near the combustion chamber. And then the 4 to 5, it means 4 to 5, and then the uh, circuit or the cycle is completes again at the number 1. Like how when the compressor starts, compressor as well as the turbine connected to the same shaft. So after doing the work on the turbine, the compressor will be shut off, and then turbine used to generate its power. That is the working of the gas turbine regenerative gas turbine. The temperature of the exhaust gas leaving the turbine is higher than the temperature of air leaving the compressor. The air leaving the compressor can be heated by the hot exhaust gases in the counterflow of heat exchanger, is called a regeneration or a regenerator, or also called as a recuperator. The thermal efficiency of the Breton cycle increases due to regeneration since less fuel is used for same work output. The next I have shown the cycle of regeneration as well as the TS diagram. The efficiency is nothing but the heat of a turbine minus heat of compressor divided by heat of, we can say, the combustion chamber. It means we can say the efficiency is equal to WT minus WC divided by The efficiency is given by heat at turbine minus heat at compressor divided by heat at the combustion chamber. The next, the efficiency is again given. The effectiveness of the regenerator, the how the regenerator can be effectively work it effectively. So it is given by, that is T5 minus T2 CPA divided by T4 minus T2 CPG. That CPA is pressure at ambient and CPG is pressure of the gas at constant pressure. Mass of the fuel added to the combustion chamber is small compared to the airflow. We can neglect the difference in mass. The next, this is the heat exchanger. Always we should know about the heat exchanger. Heat exchanger is always provided in many of the methods of improve, that is in regeneration, also in reheating, and also in intercooling. The gas turbine generates are usually constructed as a shell and a tube type heat exchanger using very small diameter tubes with a high pressure air inside the tubes and low pressure exhausted gas turbine in the multiple passes of the outside tubes. Outside of it is the shell and inside of it the number of tubes. So this is nothing but the heat exchanger. Then next part is intercooling in the compression. In the intercooling, there are stages of the compressor as shown in the figure. There is turbine and there is intercooler is provided in between two of the compressors. Then the TS diagram, let us see next. This is the actual diagram of the gas turbine with intercooling. So there are two stages of the compressor, one C1 that is low pressure compressor and C2 that is high pressure compressor. In between low pressure and high pressure compressors there is intercooler. So after the high pressure compressor there is fuel is supplied to the turbine, so that turbine works mechanically, and there is generation of electricity or there is generation of power as the turbine is connected to the generator. What is the main function of intercooler? Let us understand with the help of the TS diagram. 1 to 2, the low pressure turbine, it means the temperature increases. Then 3 to 2, mainly what is the function of intercooler? It decreases the temperature again, so that the hot air or the hot compressed air is not useful. So next 3 to 4 is high pressure compressor, again the temperature increases and entropy remains constant. Then 4 to 5, the fuel supply is there. When the fuel supply happens, the temperature as well as the entropy increases. Then 5 to 6, there is a turbine, the expansion is happen, it means temperature decreases, entropy remains constant. Then 6 to 1, the circuit or the cycle completes, that is whole about the intercooling with the regeneration. This is the intercooling is most usually used in regeneration. During intercooling, the compressor final exit temperature is reduced. Therefore, more heat must be supplied to the heat addition process to achieve the maximum temperature of the cycle. Regeneration can be make up part of the required heat transfer. That is a diagram of intercooling with regeneration. The next one is gas turbine with reheating. In the reheating, there is only one compressor and there is stages of turbine. Turbine T1 is high pressure turbine T2 is low pressure turbine. When the air is taken from the atmosphere inside the compressor compresses it so that the pressure as well as the temperature increases. Then from 2 to 3, there is combustion chamber. In the combustion chamber 1, the fuel is supplied so that the combustible material goes to high pressure turbine. In the high pressure turbine, the expansion is taking place. Then from 4 to 5, there is again reheating. What is the word? Actually reheating. In between the stages of the turbine, there is the fuel is again supplied so that there is actual reheating is happening. Heating is heating, but there is reheating again and again. Reheating, what it gives the result that reheating, there is again increase in temperature as well as increase in entropy, so that there is a improvement of the methods of gas turbine. So therefore the efficiency of the turbine is improved. That is the main purpose of the methods of gas turbine improvements. Then from 6 to 1 it comes to the original cycle, that is the reheating. Therefore a reheating cycle is used to increase the work output, while a regenerative cycle is used to enhance the efficiency. The cooling of air between two stages, compression, is known as intercooling. The loss in efficiency due to intercooling can be removed by employing exhaust heat exchange as in a reheat cycle. So this is all about the methods of improvement of the gas turbine. So